Hello everyone, welcome back to SAT Math Question of the Day. Here's our question. Please try it, pause the video, and come back and we'll do it. An electronic circuit contains three capacitors in a particular arrangement. The given equation relates the equivalent capacitance C of the arrangement to D, E, and F. It's sort of irrelevant, it's just an equation. Which equation correctly gives C in terms of D, E, and F? In other words, we have to solve for C. So this is what's I know Seth doesn't like me to categorize problems. This is called a literal problem, a problem solving for a variable. But bottom line is you got to solve for a variable. You got to isolate C and get it all by itself so that the answer is C equals something. So, I mean, maybe the best way to do it is just straight. They have to add fractions, so you have to use a common denominator. Actually, maybe we would just combine these. So that would be EF, just in this, the idea of just going quickly, that would be EF plus DF plus DE all over EDEF. And I guess you can probably flip them, can't you? You can flip them. So if you flip them,
so immediately you get answer D.
C over 1. Oh, you're right. Yeah. So if you flip them, you just look at the flip of this.
Yeah.
And the flip of this is, well, it's not that one, and it's not that one. So, yeah. So it's this one. Yeah.
Right.
Yeah.
Okay. So I think the thing that we'd like to I think we should talk about for our audience is how you got that first equation.
Absolutely correct. I totally agree. I did this in the interest of time so that people who just wanted to get the answer can get the answer. But yes, absolutely. Do you see another way to do it that's faster, that uses patterns, that without, I know you have some experience with electronic stuff, so you probably knew the answer without even doing the problem, but forget that. Is there a pattern here that you could take advantage of other than doing it the straight way, which we're going to do?
First, they are all symmetrical in DEF.
Yeah.
So I immediately saw which one it was by dimensional analysis.
Right. Yeah.
The bottom one is the only one whose dimensions are capacitance.
Or it doesn't really matter what it is. It doesn't matter what it can be ounces.
D, E, and F are capacitances.
Right.
And C is a capacitance.
Right. No, A.
So A is dimensionally correct, but it's a quote too simple.
Yeah, it looks wrong. If you have any experience,
it
with
looks
fractions,
wrong.
It's
wrong, but it's too simple.
Yeah.
And the other two are the right hand side of B is capacitance squared.
Right.
And the right hand side. Yeah, the right hand side of C is 1 over capacitance squared, or capacitance to the -2. Yeah. And C is the only one whose dimension is capacitance.
Right. So for actually, what you're really saying, rather than capacitance, is if these represent a physical thing, which they do, these are all the same unit, right? C
yes, that's what the units. Right? Units. Dimensional analysis is unit analysis. It's analysis of the kinds of units
is equal
that
to unit
that quantities
D,
are in.
Right, is equal to unit of E, is equal to unit of F. They're all the same unit.
Yeah.
So if you have something like this, you've got 3 units multiplied by each other. Just for fun, let's call them ounces. Ounces cubed. And this is ounces. So unit analysis tells you that after you do unit analysis, this this division is in ounces squared, but C should be in ounces. So you have a mismatch of units. So that immediately knocks out B and C. That's a really good way of doing that.
Yeah.
That's a very powerful for other problems. It's not just this problem. Unit analysis can really save you there's another way to look at things, another approach that's very powerful. Yeah, that's great. Yeah. So you first have to notice, you have to understand a little physics that the units are the same for all these things. Okay. Yeah. So maybe we should go through what?
Yeah, so now tell us how you knew.
Okay, so let's do
the first equation.
So let's do it the way I always like to deal with fractions, because you can make a lot of mistakes adding and subtracting fractions. So you want to combine. I'll be as neat as I humanly can be. 1 over D plus 1 over E plus 1 over F equals, now I left space. You'll see why. You have to ask what is going to be the common denominator. The common denominator is going to be D, E, F. Okay, so to get the common denominator over here, you have to multiply E times F. To get the... What did I do? To get the common denominator here, you have to multiply D times F. And to get the... Oh, I didn't leave enough
put in
space.
The denominator.
What?
Thank you.
Yeah. And then, I didn't leave enough space. I was so careful, and then I blew it. It's so bad. I didn't leave enough space. Oh, sorry, Seth.
Write it below.
So in order to get the common denominator here, you got to go E times D. E times D. Okay. So now you have to multiply these numerators. The numerators are EF plus DF plus ED. All on top.
Add the numerators.
What did I say?
Multiply.
I meant multiply 1 times that. Multiply 1 times that. Multiply 1 times that to get EF plus DF plus ED.
Oh.
Because this may be a 3, right? There could be a 3 there. It's possible, Yeah. So that you multiply these things to get the product. It happens to be multiplied by 1, and that is how you do it. I really like to leave extra space here, like I did, to leave space so that you explicitly write down what you need to do. I just cut corners just to do it, to get the answer, because people may just want to see what the answer is. And that's how I would do it. Yeah.
Okay. So I want to show another approach.
Sure. Of course. That's what we're here for. We're here to show different approaches. Can I erase? I guess.
Erase it all.
Erase it all. Okay, erase it all. Oh, and then at the end, what we did is we noted that we could flip them. We didn't talk about that, but we'll talk about that at the end.
We mentioned it. And you said, is it okay to flip them?
Yeah, but let's say you don't feel like asking is okay to flip it. If it's 1 over C is junk 1 over junk 2, then you could cross multiply and you could say junk 2 is C times junk 1. And then you could solve for C. C, you divide by junk 1. C is junk 2 divided by junk 1. And you've shown that's okay. So that's
okay. It's quicker to think of take reciprocals.
Yep.
Is a quicker to apply concept than cross multiply.
Yeah.
That is that if you have, if two quantities are equal, then their reciprocals are equal. Unless they're unless they're 0.
In other words, if junk 1 equals junk 2, then 1 over junk 1 equals 1 over junk 2.
Yeah. Well, the only condition is that junk 1 and junk 2 have to be non-zero.
Right. Okay. Well, that's a good thing to remember. Yeah.
So it's much quicker than this cross multiply.
Yes, you're absolutely
So cross multiply is used to prove.
Yeah.
that reciprocals have prove that.
Yeah. Right.
But and then so no, cross multiply is used to prove that the reciprocal of A over B is equal to B over A.
Right. Okay.
Right.
Okay.
Yeah,
Okay.
so that's
let's move on.
so
Let's
again,
move on.
it's you know, I think what is good to pay attention to when you study for the SAT is you know, problem solving shortcuts.
Definitely. Absolutely. Absolutely.
Yeah.
Absolutely. Of course. Okay. Now you wanted to show another
Yeah.
Okay. Let's see what you want. Good. Go ahead.
Okay. Show you this is my approach.
Sure.
So my approach is we're interested in C.
Yep.
And C, by the reciprocal rule, C equals the reciprocal of what 1 over C is.
Yeah.
So I would write 1 over D, 1 over the sum of 1 over D plus 1 over E plus 1 over F.
Okay.
And of course, this doesn't look like any of the choices.
Of course not.
And so I simplify this by multiplying top and bottom by 1, which is D times E times F divided by D times E times F.
Right. Yeah. Which
and
is
therefore I get D times E times F in the numerator. And then I think of how the terms work. Yeah. 1 over D, expand this by distributivity, and I can see immediately that the first term gives us EF.
Yeah.
But let me write out what I'm thinking. I'll write out what I'm thinking, but you don't have to write this out when you do the problem. By distributing in the denominator multiplication, I get 1 over D times DEF plus 1 over E times DEF times D times E times F, of course, plus 1 over F times D times E times F. And then the D's cancel and we get EF. The E's cancel and I get DF, and the F's cancel and I get DE. So I get
right.
This result.
And also I noticed that at this point, all you have to do is do this one. Oops. Sorry. Oh, wait.
Yeah.
All you have to do is do this one, and immediately this is the only answer that has
that's right.
that pattern in it, and you can stop.
Yeah.
Right. Yeah. I never grew up learning how to simplify what's called a complex fraction using the common denominator of both fractions. I just never learned. They never taught that to do it that way, so that wouldn't necessarily have occurred to me. Too bad we learn things when we're young and we're stuck in those patterns, isn't it? Really hard to break old patterns.
Yeah.
But yeah, but now they do that. Maybe now they do that because they know that you're going to get a question like this on the SAT. But now I think they teach more that if you're going to simplify what's called a complex fraction, a fraction on top of a fraction, you multiply top and bottom by the common denominator. That's a nice way of doing it. That is really nice because this way you don't have to.
It's more elementary.
Yeah. Right. Yeah, but you do have to. But you do have to know that you can flip. That if you have something, if you have two things that are equal, the reciprocals of those things are also equal. And also, this is a little scary. You must admit, this is a little scary.
Well, it's a little scary.
It's a little scary.
Yeah. It's a little scary. Don't be scared, though.
Right. Yeah. Okay. Well, this is good today.
Yeah. Math. Math doesn't bite.
Right, right. You just have to see enough stuff, do enough problems to
Yeah,
have some
yeah.
experience with these things.
But it's you know it's for it's much better and to intellectually to be aware of many of several different approaches and relevant facts as opposed to just remembering the very first one that someone taught you.
Yeah.
Or
yeah.
perhaps you thought of yourself.
Right.
The more different ways you have of thinking of something, the more powerful an intellectual you'll be. An intellectual will you be.
Absolutely, absolutely, and that's why today was good.
And again, I think what you know, what we're doing, what I want to do here is instruct our audience to become more powerful intellectuals.
Yes.
Not just get better grades on the SAT.
Yeah. Oh, absolutely. Absolutely. That's why we have different approaches. By the way, there's another crazy approach that you can use, which is highly not suggested. But you can make up numbers for a C. Oh no, you can't make a number. No, I guess you could try it out. You could let D be 1, E be 1, and F be 1.
Yeah. The trouble is if they're all ones and the several answers come out.
Right. So C is 3.
Can make them all 2s.
Yeah. No. Oh, right. A half plus a half plus a half is 3/2. Oh, that's really complicated. Let's forget it. If you could do that, then you could probably do it the other ways that are easier. That would be bad, right? Yeah. If this was a 2, a 2, a 2, then that's 3/2. So, oh, forget it. It's too complicated.
Yeah.
Okay.
Well, I think I'd say that we're studying for the SAT. Learn to do the algebra.
Yeah, of course.
Yeah, algebra is in the subject. So learn it. If you haven't learned it as well in class, learn it now from us and from other resources.
Yeah.
Lots and lots of video resources for all sorts of math.
That's right. A lot of it there. Okay, so let's answer our questions. First of all, calculator. This came from an old, not that old, October 2023. This was a non-calculator question. This is now obsolete because now the entire SAT, digital SAT, is calculator. But obviously, calculator is not really going to help you here. Would you, does guess and check make sense? Does it make sense just to look at the answers and pick the one? No, does look at the answers and choose and just test each one? Not really. Although one can use unit analysis to discard those, but that's a different question. We're talking about literally taking the answers and plugging it in. That doesn't really apply. Would you do this question different from when you were in school? Not really. I mean, then really you would do it the way I did it or the way Seth did it. And the main idea of the question. That's the key question. What are they, the test takers, trying to see if you know what to do? And here it looks like solving for a variable and also combining fractions.
I think the main idea is simplification and transformation of compound fractions. Compound fractions, I guess is the word right?
Well, that's the way you did it. That's the way you did it. That's not.
Well, no. If you've compound, would you consider your identity the identity you started with an identity that pertains to compound fractions?
No, the method I used was adding fractions with a non-common denominator.
Okay, so call it the algebra of fractions.
Algebra of fractions, but there's bigger concept that may elude people. This whole potentially scary, and Seth hates when I say that, question of solving for a variable. Solving for something that isn't X.
Yeah.
We're all used to solving for X. But here, you have to solve for this thing in terms of the others. For example, someone may be totally okay with this problem. 1 over X is 1/3 plus 1/4 plus 1/8. No problem. People think, oh yeah, I could do that. I could just combine the fractions and I either cross multiply or I flip them. No problem. But it becomes a whole different intellectual exercise when you have to do this. Solving for C in this problem. Even though it is exactly this very, very similar, for people who are, it may not be this. It's a different. It calls upon a different intellectual exercise, I think. Even though it is really the same, but it doesn't look like it's the same at first blush. So that's
the same to me.
I know. But solving for a variable, in terms of other variables, unless you have some experience, is a little like, what? What do I do? I don't know what to do. So anyway, so that's also a big part of it, is that you have to be used to solving with these problems called literals, which are usually done in Algebra 1. So. But
that circled question could be easily solved with a calculator.
Yes, it can be. That's why if the SAT wants to test you with dealing with fractions, they're going to do it in this form where you have variables. So, okay. So I think we're done. Right?
This one you could, if you do it by hand, you could simplify this pair to get 3/8.
Right. Yeah. Okay. So I think we're done, right? So I'm Joel. I have a PhD in mechanical engineering from Brothers Seth. Looks like it's a nice day up there in beautiful wherever Seth is.
Yeah.
Seth is a PhD in math from MIT. He's been teaching computer science for many years at SUNY Albany, and he's now retired. We're here to offer different approaches. We do one SAT question a day. We come from different people, and we have different educational backgrounds, and we think differently. So we come with different approaches, which is good. But we all agree that the best way to study, the approach to study for the SAT, is do as many practice questions as you can. Take them as diagnostics. Learn which subjects, which areas you're weak on, and do more of those questions to bone up and study the units, the topics that you are weaker on, and then toward the end of the study cycle, take as many practice SAT questions take as many practice SAT tests as you can from the College Board. And then please give us comments on our videos. We really appreciate all the comments. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com.
Yeah, the email address is in the title page, in the YouTube page of our channel.
That's right. Absolutely right. Okay, Ren. So have a great day. Take care, buddy.